There is a lot of excitement about hydrogen at the moment. World leaders believe that it is an important element of the just energy transition, something that is going to help the world cap global warming at 1.5 degrees relative to pre-industrial levels. African governments really be investing a fortune on developing hydrogen value chains? Let's find out. Hydrogen is one of the most abundantly available elements in the universe. We have it here, for example, in water. 2 hydrogen atoms and 1 oxygen atom, H2O, which produce water. It is the #1 element in the periodic table. We sort of also see it around the sun because there is a lot of hydrogen around the sun, and there's nuclear fusion happening all the time, bonding about 4 hydrogen atoms and creating helium. Exactly how is hydrogen produced? There are several ways. You can, for example, concentrate searing heat on water, and this would split the hydrogen atoms from the oxygen ones. The fuel stock used differs from company to company. But then also there is another process that is much cheaper and much more readily available around the world that can be used, and this is electrolysis. And in this process, water is passed through an electrolyzer, and the splitting process happens, separating the hydrogen from the oxygen. Not all hydrogen is created equal, and the hydrogen spectrum classifies hydrogen using colors according to how the hydrogen was produced. That is, according to the main fuel stock that was used to produce it. And so we have, for example, black or brown hydrogen that is made using coal as the main fuel stock. We have gray hydrogen that is produced using gas, methane. There is blue hydrogen, which is produced using gas, but then the claim is that most of the CO2 produced in the process is recaptured and sequestered. Well, those are claims that have been debunked by some people. And they say that as much as 80% in some processes escape into the atmosphere. There is pink and purple hydrogen, which is made using nuclear electricity. And then the one that everyone is excited about, there is green hydrogen that is made using renewable energy. That is energy that was produced through solar, wind, or tidal, for example. Well, the science behind hydrogen is not necessarily new. It has been with us for centuries, really. Writing in The Mysterious Island, a novel that was published in 1874-75, Jules Verne says that water is the coal of the future. Tomorrow's energy is water that has been decomposed by electric current. The elements of water thus decomposed, hydrogen and oxygen, will secure the Earth's energy supply for the foreseeable future. So hydrogen has been used really for a long time. So why did it not really become popular? The thing is this: if you can burn coal directly and produce the kind of electricity that you need to run a factory line, to make steel and so on, why do you need to transform it into hydrogen before you use it? This is really the question that people used to ask themselves, and that is why the hydrogen science never really became popular. So a number of new innovations are generating excitement that hydrogen can be used in the number of processes that really reduce our carbon footprint. For example, hydrogen fuel cells are being used in small aircraft, hydrogen cars, and manufacturing processes already. This is how the process works. Hydrogen is introduced through the anode, and a catalyst splits it into protons and electrons. The positively charged electrons is re-released, and that is what generates electricity. The oxygen passes through the cathode and it is then re-released as pure water. Electric vehicles, for example, already have a massive ecosystem of charging stations from the Seychelles all the way to California and back to Mauritius. Also, there have been a lot of investments in electric vehicle technology, and I don't see the companies that have made these investments reversing those decisions to start investing in hydrogen. That said, hydrogen still has a number of very important potential uses. It could be used, for example, to make fertilizers. It could be used, for example, to power trains, tramways and trams, power buses, cement manufacturing, transportation of cargo with ships and so on. And so it is really in these areas, that is in heavy industries and heavy industrial processes, that hydrogen can still potentially play a very important role. Although hydrogen is not going to replace electric vehicles, there is still a lot of excitement around it. Why? Well, the reason is simple. A number of major governments, Germany, France, Japan, the USA, for example, at least the state of California and others, are betting on it, and they are investing heavy amounts of money on it. Germany, for example, recently launched a 7 billion euro tender for green ammonia. And right before COP27, they launched a second tender for about 9.7 billion euro. And so all this money is going to generate a massive ecosystem that will soon be able to participate in the just energy transition process. So what is green ammonia, and why is everybody talking about it in connection with hydrogen? Well, ammonia gas is this pungent gas which is a mixture of hydrogen and nitrogen, and it is used to produce ammonia, which is used in agriculture. Last year, over 200 million tons of ammonia was produced. That is really a large ecosystem. And some people believe that ammonia gas holds the key to transporting hydrogen. The hydrogen and the nitrogen would be combined to produce ammonia gas, which is then transported on ships and possibly reburned to generate hydrogen where it is needed. Well, remember that in the just energy transition process, we need to cut emissions. The Conference of the Parties has decided that we need to cap warming at 1.5 degrees relative to pre-industrial levels. And to do that, in order to achieve that, we need to cut global CO2 emissions by at least 50% by 2030. That is a really large number in such a short space of time. And so African countries are poising themselves to be exporters of commodity. And in the future, you will have exports of not only liquefied natural gas and crude oil, but also green ammonia leaving Africa for Europe. Now, to make green hydrogen, to make green ammonia, you need a lot of green energy. At the moment, South Africa has only about 10 gigawatts of installed renewable energy generation capacity, 10,000 megawatts. South Africa's energy fleet is largely coal-based, and it used to generate about 55 gigawatts of electricity, but that capacity, due to its age right now, is producing less than 37 gigawatts of electricity reliably. And so South Africa's first priority really should be keeping the lights on. And that means certainly that it does not have the money at the moment for a hydrogen value chain. Unless, of course, these investments in hydrogen are going to be completely private-based.